Okay, basic idea of induction you all understand. Now we talk about presentation. Correct? There are two parts to the mathematics education, right? One part is about knowledge and learning. The other part, we must still get our A. Correct? No choice, no choice. Let's be practical. Okay? So in exams, you may know the idea of induction. If you don't present properly, you lose precious marks, and I don't think we want that. Okay? Okay. First step. Let's use an example to, I'm not going to go through this one. I'm using the example to go through the 1, 2, 3, 4, 5, can? So if it helps in your presentation, you can label 1, 2, 3, 4, 5 in your induction problem. Okay? Example 3. Example 3 need us to, I need to write a lot, I better sit down. Huh?
7 months.
Is it 7 months cannot take chair? Goodness. Don't scare me. Okay. Example 3. You have to use induction to prove this. Okay, to prove this. And can we pay close attention to this part? Sometimes they will give you this, sometimes they don't give you this. This will give us an idea what is the smallest n. Correct? Because you want the first domino to fall. And the first domino may be n equals to 2, and in just now, the triangle, the polygon case, it was n equals to 3. Yes? So let's take note. Okay, first step, state the proposition. Wow, a lot of writing. I also need to write with you. Okay. What do we mean? We have to let Pn be the statement. Why do we want P? Because in this thing, it's not defined. So we define what does P subscript n mean. Okay, let Pn be the statement. 2 over 3 factorial plus 3 over 4 factorial plus 4 over 5 factorial plus dot dot dot. 3 dots, not 4 dots, not 2 dots again, must be 3 dots again. Equals to half minus 1 over, just copy okay, 4 and greater or equals to 2. It's just the definition of the statement, so that actually someone asked, why need to write this again? Yes, this statement is just to define Pn, so that later on when we say pk plus 1, we don't need to repeat, right? We repeat this whole thing all over again. Because if this is Pn, pk means replace the n with k, that's all. You know what I'm saying? To save us a bit of writing later on. Okay, step 2. Prove that PA is true when A is the smallest possible value of n. That means the first domino. Okay, analogously is the first domino. So we will consider what? Consider P2. Okay. Those of us who are sleeping can wake. Those of you, can you wake up your neighbors who are sleeping? Okay. Okay. A lot of copying. So one more asleep. A lot of copying. Consider P2. And here is the presentation bit. Let's be very careful. Okay. We cannot be slingshot here, because the statement is this. The statement is this. We are trying to say that we're trying to prove that if I sub n equals to 2 on the left hand side and I sub n equals to 2 on the right hand side, they are equal. So let's be systematic and we say, okay, left hand side of P2 equals to what? Alright, equals to what? And then we are also going to later on going to write right hand side of P2 equals to what? Now these two, you are to show that they are the same. You follow what I'm saying? That's what we want to do. So we are making use of left hand side and right hand side. So left hand side means what? Here, left hand side of P2 just means that you stop at 2 over 3 factorial. So it's just 2 over 3 factorial. Let's be very clear. Can you jump from here? Can you jump from here to here? That means don't write this. Cannot. Better write this followed by this. Because you are being very explicit that you are making use of left hand side. Don't use mental sums here. Don't show off your mental sum here. This is not the right place to show off your mental sum. Follow? Okay, maybe I should write. This is not the place to show off mental sum. Can? Okay, not the place to show off mental sum. Next. What about right hand side? Right hand side is this. Is this thing. So better write. Replace n with 2, you get half minus 1 over 2 plus 1 factorial. I'm being a bit kiasu. Or better make sure you explicitly substitute n equals 2 on the right hand side, not left hand side. Then okay lah, here can as long as you show you get 1/3. Can? At the end of it, we conclude properly, can? That means left hand side, right hand side are equal. We conclude properly that we say, okay, therefore P2 is true. With no doubt, P2 is true. Can? Okay, step number 3, assume PK is true for some non-negative integral value of K. For some value of K lah, okay? For some value of K. Actually, okay, never mind. So in this example, we assume PK is true for some K. Now, can I highlight this word some? I'm not assuming PK is true for all, just for a particular K. In the middle of the dominoes, I assume some K. Not good enough like that because, can I have attention? Now, K cannot take on 1. Correct? K cannot be 1 because the first case is already 2. P2 is true. So for some K that is greater or equals to 2. Can? As long as K is greater or equals to 2, okay, for some K can be anything. But it must be greater or equals to 2. Can? Okay, to be clear what we are talking about, I would like to write this line and I would think that it's useful to all of us to write this one. What does it mean for PK to be true? Copy. Essentially, I just replace the n with K, right? Next, use the above assumption. Remember, we want to use PK true to prove PK plus 1 true. Use the above assumption. So, we will say that, okay, this one, okay, never mind. We want to show PK plus 1 is true. Correct? We want to show that PK plus 1 is true. Can? So now we write left hand side of PK plus 1. So we write okay, sorry. I would generally like to write right hand side first. Why? Because usually the right hand side is the simpler one. Correct? We write the right hand side first. Right hand side of pk plus 1 is what? Is sorry, can I? Sorry, I mean of pk plus 1. Okay? Minus pk plus 1 means you replace the n with k plus, that means k plus 2. Our objective this is the meat of the proving process. We are eventually going to prove somehow here in this or this space here to prove that somehow this will be equals to the right hand side. We aim towards the right hand side. That's the reason why I write the right hand side first. Follow? Okay. What is left hand side? Left hand side of pk plus 1 is just write lah. Oh. Which is what? Which is we start off with 2 over 3 factorial plus 3 over 4 factorial plus 4 over 5 factorial plus plus k over k plus 1 factorial plus k plus 1 over k plus 2 factorial. Correct? The last term should be this. I'm writing the second last term just for completeness. You will realize why I write the second last term. Okay, I'll explain why I write the second last term as well. Remember, we must always use the fact that we must always use our assumption to show pk plus 1 to be true. And in this case, if you look very carefully, this one here, what is this equal to? Using our assumption. If our assumption is true, 2 over 3 factorial, 3 over 4 factorial, all the way to k over k plus 1 factorial here, yes, must be equals to this. Using the assumption. We must always use the assumption. Okay? So using the assumption, we will say this is equals to half minus 1 over k plus 1 factorial plus k plus 1 over k plus 2. This step is very important. We must make use of the assumption. Okay? May I write down? This one is just a comment. Make use of the assumption pk. We must somehow within this step number 4, we must make use of pk. If your step number 4 have not made use of pk, then something is wrong. Follow so far? Must make use of pk. Now our job now is to aim towards the answer. Very loosely speaking, aim towards this answer. From here, we aim here. Now we already have a half, we had a half here, so leave the half alone. Now we're supposed to prove this one is equals to this fraction. How do we do it? Very simple. You have a k plus 2 factorial. Make a common denominator. Correct? Common denominator. Okay, minus, I put it like that, can? Can? And then I have a common denominator, k plus 2 factorial. How do I have a common, how do I make this denominator to be k plus 2 factorial? I multiply top and bottom by k plus 2. Can? I multiply top and bottom by k plus 2. Correct? This divide by this, it will give me this. Remember, I record it. Just take note that this is a minus. Okay? But this is a plus, so I have a minus k plus 1. Correct? Let's take note of our sign. Minus, minus become plus here. Just check that. Okay, I'm just combining the two fractions. I get half k here. K minus k I get 0. 2 minus 1 I get 1. Wow, magic. Now left hand side equals to right hand side. Right? Now left hand side equals to right hand side. Got space or not? No space. Never mind. Supposed to write here. So equals to right hand side of pk plus 1. Now therefore, what have we shown so far? We have shown that pk true imply pk plus 1 true. We have shown that pk true imply pk plus 1 true. Okay. Can we please write this green highlighter part in full? I have not shown that pk plus 1 is true. I am only making use of an assumption pk true to show pk plus 1 true. So please don't write pk plus 1 true only. Have to write in everything. This implies this. Okay? Don't write this only. This is things that I say and things your seniors have lost precious marks just because you don't write everything. Follow? Okay? Because I have not shown that the k plus 1 domino has fallen. I'm just saying that if the k domino has fallen, the next domino will fall. That's all. Yes? Okay. Last step. Conclusion. Conclude the proposition is true by induction from the first case onwards. So, can we write? Since P2 is true, and PK true imply PK plus 1 true, therefore by mathematical induction, Pn is true for all n greater or equals to 2. It makes perfect sense, you know. It's just like the domino example. The first domino fall, and the k domino will cause the k plus 1 domino to fall, so every domino will fall. Can? Not too bad, right? Then after that, I don't think there will be that much copying. Okay, only this example a lot of copying because I want you to get a sense of, get a feel of writing. Okay.